Hello, boys and girls. This is Mrs. Gwen Gervasio, and today we're going to be covering Chapter 9, Lesson 9.1, Surface Area of a Prism. Reference pages to this can be found in your Google Classroom, pages 9.1, pages 356 to 358. Okay, so let me go ahead and give you a warning about this chapter. This chapter could be challenging if you don't pay attention and do practice problems, okay? So make sure you really pay attention to the videos and in class for this chapter because it could get challenging, especially with all the formulas that we have. So speaking of formulas, here's our first one. This is going to be the rectangular prism formula. So what a rectangular prism is basically, or any prism, is when you have a three-dimensional shape, and in this three-dimensional shape, you can put something inside. If you can put it inside, it's a prism. So we have here this rectangular prism. Now, what we're going to do is we're going to find the area, and the area is not what's inside, what you can fill in, but it's the outside pieces. If you were to take it apart, what's the whole space of the outside pieces? Not the inside, that's volume for next chapter, but the outside, okay? So if you look at this rectangular prism, we're going to go ahead and study this rectangular prism. We notice that there's a top base and a bottom base. So that's why there's two here. And then around here, there's a around the edge or around the box. These are called faces. So there's 1, 2, 3, 4 faces. But for these faces, two of these are the same. So this one's the same as this one. But then we have here this one is the same as this one. Okay, so if you look at this formula, it might not make sense yet until I show you our first example. It says here, two of the bases, L and W, so it's going to give you part of the surface, and then we have two LH and two WH. What these are, the one in blue, those are the faces. The one in red are the bases for the top and bottom. What we're trying to do is we're trying to see how much space perhaps does it take to maybe color this whole entire box. So let's go ahead and start with our first example so that you can have a better understanding of how to use this formula. So we have here, it says here, surface area of a prism. So we have here this prism, and in this prism we have a top base and a bottom base. So I'm going to go ahead and point out the bases, the top base and the bottom base. So what this is going to be is for the bases. So since there's two of them, we've dropped down the two. And since we know what the length is going to be 5. We'll put 5 here. And since we know that the width right here is 3, we're going to put 3 here. Again, we're trying to figure out the area of each piece individually, and then we'll know all of it together. So 2 times 5 is 10. 10 times 3 is 30. So we have 30 for this piece. And then now we're going to go ahead and move on to our next piece. Our next piece is going to be the faces. So our faces is going to be, we can do this face right here is the same as, can you see? It's three-dimensional. So you kind of have to really look at it, this piece. So this piece, let's choose the one in the front here, the one in the back. So that's going to be 2 of them. Since there's 2 of them, we'll go ahead and put 2. And then the length of this is going to be, watch carefully, the length is going to be 5. And then the height is going to be, well, since I don't know the height here, look over here. It's the same thing. The height is going to be 6. So this height is the same as this height. So that's going to be 6. So again, you really have to look at it carefully when you look at these three-dimensional figures, okay? That's all this chapter is going to be about, looking at these shapes. So 2 times 5 is 10. And 10 times 6 is 60. And why do they all have a 2? They all have a 2. Let me go ahead and highlight that for you. They all have a 2 for a reason. The reason why they have a 2 is because there's 2 of each. So there's, there's two bases and there's 2 faces of each. Okay? So now we're going to go ahead and do the last one. And then in the last one, let me go ahead and change my pen. And in our last one we have here is going to be the other piece that we didn't do. So we did the side one right there. Let's go ahead and do the last one. And our last one is going to be the one in the back. So we'll do the back piece here, the one here, and the one right here. So the 2 is always going to stay because there's 2 of them. One here, one here. The width is going to be 3, so we'll put times 3. And the height is going to be 6, so we'll put 6. So 2 times 3 is 6. And then bring down the 6. 6 times 6 is 36. So now you have the 3 numbers you can add up. We have 30, 60, and 36. And if you add up all 3, we're going to go ahead and add it, add, you'll get a total of 126. So if I were to buy, let's say, wrapping paper, I need 126 inches for this, inches squared for this wrapping paper. So that's the surface area. How much space you need for that, for the whole entire box outside. Okay, if you didn't understand something in this part, go ahead and stop it and watch it over again so that way you can understand it. Again, you're doing them piece by piece, two bases and the faces. So go ahead and do this one. went ahead and wrote down the formula for you just in case if you need. This is the base, the purple part, and this is the face. Together you combine them, that gives you S, surface area. So do number 1 and number 2. Pause the video if you need more time. I'm going to go ahead and move on. So in our next one, you would need to know the surface area of a prism. Now, if you're thinking, isn't that the same formula in the last example? Not exactly. A prism can also be any prism. In other words, it doesn't have to have like a box or a square for the base. It could be a triangular base. So we write down this formula, surface area equals area of bases plus area of lateral faces. If that doesn't make sense, I'll show you the next example. So make sure you write this down. If I'm going too fast, pause it and you can watch it, hear it again. Okay, so after you wrote down that formula, again, what was the formula? It was S equals area of base, so area of the base, area base, plus area of what? Face. So it's always base and face, so area of face. So if you look at this shape right here, this prism, we have not a rectangular base anymore, but we have a triangular base. So if you look at it, it has a triangle base now. So you look at here and here, it's a triangular base. So what we're going to do is we're going to find the area of that triangle. So to find the area of the triangle, it's going to be 1/2. Remember in the last chapter, 1/2 base times height. So what is our base? Let's look. Our base is going to be 3. So 3 is the base. What's the height? Our height is going to be 4. It's not the top here because that's a slant, so 4. And then times it by 1/2. What's 3 times 4? That's 12. Times it by 1/2. That means cut the 12 in half. Half of 12 is 6. But because there's 2 of them, we're going to multiply it by 2. So the answer is back at 12. So that's just for the triangle. Now, what we need to do is we need to find the area, and I spelled area wrong. Let me add another letter. The area of our, now when I say face, it might have faces. Okay, so to find the area of the face, what we're going to do is we're going to go ahead and figure out how many faces we have. I noticed that we have 3 different faces. There's one in the back that's really large. So let's go ahead and do the one in the back, that big rectangle. That face is going to be a rectangle. So it looks like it's a 5 by 6. Remember, area of a rectangle is length times width. So length is 5 by 6. What's a 5 by 6? That's going to be 30. 5 by 6, that's a times, by the way. Let me change that to a dot. So 5 by 6 is going to be 30. So we have here 30. Let me change that to a dot. So 5 by 6 is 30. And then what we're going to do is we're going to go ahead and move on to the next one. So I noticed that in the next piece we have here is going to be another rectangle right here. This one is going to be a 4 by 6. So length times width again. Notice I said faces. Okay, so this is another face. Length times width. So our length is going to be 4 and our height or width is going to be 6. So 4 times 6. What's 4 times 6? 4 times 6 is going to be, 4 times 6 is 24. So we have 24 here. And then let's go ahead and do our last piece. Our last piece we'll do it in red. It's going to be the one, now pay attention, it's going to be this one right here. The one that we forgot right there. So that's going to be a 3. And what's the height? 6. Let me erase that really quick for you. A 3 by 6. Can you see that? That's a 6. So a 3 by 6. So follow the red part. So 3 by 6. So we're going to put here length times width. Length times width. Length times width is 3 by 6. What's a 3 by 6? A 3 by 6 is 18. Now, what I'm going to do with all the numbers that I found the total for is I'm going to go ahead and add it all up. So I have here 12, 30, 24, and 18. That's all the pieces together. And when I add it all up correctly, I will get a total of, let me go ahead and switch markers. I'll get a total of, let me go ahead and add that up really quick. I'll get a total of 84. So I'm going to go ahead and write that down, 84. So 12, 30, and 24, and 18. Let me go ahead and double check that just to make sure that 12, 30, 24, and 18 is 84. So the answer is 84. Final answer. What we did is we just took each piece. Again, finding surface areas is just finding the area of each piece by itself. Very, very important. Each piece by itself. Okay? So go ahead and pause the video. Go ahead and try example 3 and 4. Okay? All right. In our last example here, it's the surface area of a cube. So make sure you write down this formula. So far you should have 3 formulas in this video. This is the third one. S, which stands for surface area, equals 6s squared. And what does that mean? Let me go ahead and show you a picture of a cube. So I have here a cube. It's basically a perfect square all the way around. All the sides are the same. So what S stands is for surface area. So what we're going to do is put S equals 6 for the 6 sides this box is. If you were to count it, there's 1 piece. The one on the bottom, that's 2. The one on the side, that's 3. The one on the side is 4. The one in the back is 5. And the one in the front is 6. There's 6 sides, so we're going to put the 6. And then what we're going to do is we're going to put what S stands for is S stands for the side. So we're going to look to see what's the side. The side of this is going to be 12. They're all the same, 12. So we're going to put times 12. But 12 needs to be squared. So we put 12 squared. And so we're going to say 12 squared is 144. So after we have 144, we're going to multiply that by 6. Again, 12 squared, let me go ahead and redo that for you. 12 squared is basically saying that we're going to go ahead and do 12 times 12, which is 144, and then 144 times 6. What's 6 times 144? That will give you a total of 864. And this is going to be the area for a cube, a perfect cube, kind of like the Rubik's Cube that you see sometimes students play. So there it is. And this is probably the easiest formula for today to do. Okay, if there's something you didn't understand in this video, again, go ahead and replay it, watch it over and over until it makes sense. Okay, all right, on your own, if you can try to figure out which one is greater, the cube or the surface area of this prism. You have to solve for both in order to find that out. All right? All right. So there's no exit ticket today. So again, go ahead and jot down the notes that are needed, ask questions, make down notes, and then please ask me the questions tomorrow. Have a great day.